Hello, this is Brett Etheridge, founder of Dominate the GMAT, here with your GMAT tip of the week.
The tip for this week is to use logic and look for shortcuts to save yourself time on GMAT problem-solving questions. You know, when it comes to doing GMAT math, you don't always have to do it by the book. You don't have to take excruciating pains and detail to do every single step-by-step part of the problem. There usually comes a point where you can jump to the head of the class, where you can save yourself a little bit of time. Now, I'm not advocating that you do work in your head. You know I'm a big proponent of using your scratch paper to avoid careless errors. I'm not suggesting that at all, but what I am suggesting is the difference between scoring in the low to mid 600s to the upper 600s, or even cracking 700 and then getting even in the upper 700s, is not only knowing how to do the more difficult questions, but knowing how to do the more difficult questions more quickly, to get to a point where you figure out that you can actually get a right answer without going any further with the math. Let me show you what I mean, but first I'm going to give you a chance to try this problem on your own. Go ahead and press pause and see how you do. All right, so how'd you do? You know, it is a fairly difficult question. I can understand if you had some issues with it, but let me show you some things. Even if you think you got the right answer, and bear with me, let's see if you noticed a couple of things that would have enabled you to save some precious time that'll enable you to get more right answers down the line. Obviously, you start this question by writing out the area formula for a triangle, because that's what we're trying to find. No, it tells us the area. We're trying to find z, but we got to start with the area. So it tells us, that the area is 24. Well, we know the area is 1/2 base times height. Well, in this case, the base or the height is x, I guess. I wrote this backwards, and the base is y, but that doesn't really matter. And we know that that's going to equal 24. And then we want to get rid of fractions, so let's multiply by 2. So we recognize that xy is going to equal 48. Now, this is crucial because at this point, this is where you could go a totally different path and get a right answer by saving yourself a lot of time without having to do the math. You may have ventured down the path of actually doing the math. And my purpose isn't to teach you how to do that, but let me just scratch it out real quick. Obviously, it tells us that x equals y plus 2, so we could substitute that in, and we could say that, so y times y plus 2 equals 48, and then we say, looks like we got some quadratic equations going on where y squared plus 2y. Let's subtract the 48 to the other side because we know we like to set quadratic equations equal to 0 so that we can find the factors, so that we know it's y. Let's see, 6 times 8 is 48. It's got to be positive 8, and then negative 6, so y minus 6 equals 0, and then we could solve for y, right? Y can't be negative, so y is going to have to be positive 6. All right, if you didn't understand that, go check out my lesson on algebra and quadratic equations. But that would be the long way of going about it. And then we could say, okay, well, x is y plus 2, so that means x equals 8. How could we have done this faster? Well, what we could recognize is that once we see that x times y has to be 48, how many possible combinations are there even, right? Well, we could have 1 times 48 equals 48. So those are possible values for x and y, right? I mean, that's essentially what I'm doing. We could do 2 times 24. It could be 3 times 16. It could be 4 times 12, right? 5, 6. It could be 6 times 8, right? Those are the possible values. And what we know about the rules of triangles is what? And this is what I'm really getting at. The hypotenuse has to be longer than the longest side. So let's say this weren't drawn to scale, and we had a triangle that looked like this. Super skinny down here, that's only 1, and way up here is 48, right? We're assuming these dimensions. What does that mean about the hypotenuse z? Well, z is going to have to be at least as big as 48, so it's going to have to be greater than 48. What do we notice about the answer choices? Even the biggest answer choice at 10 is not even close to 48, so that's not right, right? And actually, we know that with problem-solving questions, we want to assume the figure is drawn to scale unless otherwise indicated. So it's probably a pretty good guess that the dimensions are going to be 6 and 8. And what do we know at this point? We know that the hypotenuse has to be longer than even the longest side. Well, the longest side here is 8. The short side is 6. We recognize that answer choices in GMAT problem-solving questions are in either ascending or descending order. So that enables us to eliminate A and B as well. Now we've gotten to answer choice E so much faster. A lot faster than if we did all of these steps doing quadratic equations. Maybe you got hung up here figuring out the factors, and you spent an extra 30 seconds to a minute solving for X and Y. This is a different solution, and that's the type of thing that you want to do to save yourself those precious seconds. Worst case, let's assume you went through all of that doing quadratic equations to solve for X and Y, and now we know that we do have 6 and 8. Here's the other thing. Either A, you recognize that the hypotenuse has to be longer than the longest side, which leaves us with answer choice E, as I said, or what did I teach about right triangles? And if you haven't watched it yet, go check out our triangles video. Because it's crucial that you know right triangles inside and outside, but you recognize that this is in essence a 3, 4, 5 right triangle. What you don't want to start doing is the Pythagorean Theorem. If you started ever, when you were doing this problem, 6 squared plus 8 squared equals z squared, and then you start doing that and solving for z, you have missed something. Remember, I always say, if you're doing the Pythagorean Theorem on the GMAT, you've probably missed something. Not always. Sometimes you have to do it, but here, what have you missed? You've missed the fact that this is a scaled-up version of a 3, 4, 5 right triangle, which is a common right triangle you should know. Another way that you can save some time and figure out right away that the hypotenuse is 10 without actually having to do the math of the Pythagorean Theorem. So lots of different things going on in this problem, all of which put you in a position to save precious time, not by making careless errors, but by looking for shortcuts. And at some point in the process, maybe right here, once you recognize that x times y equals 48, you can jump to the head of the class. You can start to eliminate wrong answer choices just by using a little bit of logic and save yourself those 30 seconds, maybe even a minute or more that you can now apply on later questions, all of which is going to add up to a higher GMAT score, enabling you to go out and dominate the GMAT.